2.3 is on solving right triangles. We are going to use trig functions with acute angles to find missing parts of a right triangle. So some of the problems in the book will talk about significant figures or significant digits. They mean the same thing. And it is, when you're talking about a number, significant figures of a number is found by counting all of the digits from left to right, beginning with the first non-zero digit on the left. So, for example, 0.42 has 2 significant digits. And then when we look at the next one, 0.005, this one we're going to include all of these because these are the placeholders to get to the 5. So this one is going to be 3. The next one we are also going to have 3. Because after the decimal we've added those 3 zeros, that means those are included in the significant digits, which would make that 4. This example only has 2 because there is no decimal point, which would make this one 1 as well. You're going to round your answers to the number of significant figures that the given information has. So usually if it doesn't tell you where to round, you'll round to the same place that the information that was given to you. So if they have to 1 decimal point, you would round your answers to 1 decimal point. Make sure you read the directions though, because sometimes they might specify where they would like you to round. So for example 1, in right triangle ABC, remember C is always our right angle, A is 40 degrees, and side length C is 12. They want us to find all of the other missing pieces, which would be side A, side B, and angle B. I'm going to start by finding angle B. In this one, angle B is going to be equal to 50 degrees because it's the complement of angle A. Now that we have that, we can go ahead and solve for our missing sides. I'm going to work with angle A as my primary angle, which would make A the opposite and B the adjacent. Now we can use our trig ratios to solve for our missing sides. To start off with, I'm going to do sine of 40 degrees equals A over 12. To solve this, we're just going to multiply both sides by 12. Which will give us the value of A. And then this one, our answer has 2 significant digits. So we're going to round this to 7.7 for the side length of A. Now, to find side length B, you could do one of 2 things. You can use Pythagorean theorem, or you can use another trig ratio. I'm going to show you how to do it with another trig ratio. For this one, we would do cosine of 40 degrees equals B over 12. And again, we will multiply both sides by 12. 12 cosine of 40 equals, and we're going to round to 2 significant digits, which would make this 9.2, which is about equal to B. For full credit on a quiz or a test for a problem like this, you would have to show all 3 of these answers. Next, we're going to be doing another similar example with a right triangle where A, side length A, is 2.73 and side length B is 3.41. This time we need to find the remaining sides and angles. So I'm going to use Pythagorean theorem to find side length C. We'll take 3.41 squared plus 2.73 squared. That's equal to C squared. And I'm just going to type that into my calculator really quick to figure out what these all equal. And we will have 11.6281 plus 7.4529. And you don't want to round until you get to your final answer. And that way your final answer will be more accurate because you waited to round it. Otherwise, you'll round multiple times and it can really throw off your final answer. So then from here, we'll take the square root of that number, and our answers have about 3 significant digits. So for this one, we're going to do 4.37 for side length C. Next, we can go ahead and find our angles. I'm going to start with angle A. And they gave us what our opposite side was and our adjacent side. So I'm going to go ahead and use my inverse tangent function to figure out what angle A will equal. Then from there, I can use that information to find angle B without having to do another trig ratio. So angle A is about 38.7 degrees. And if we take 90 minus 38.7, we will get angle B is equal to 51.3 degrees, which is our final answer. Next, we have example 3. In this one, we have a circle which has a center at C and a radius of 18 inches. If triangle ADC is a right triangle, they want us to find x, which is the distance from point A to point B. So looking from angle A, which is the one they gave us, we know that we have the opposite side length, and these two together would be our hypotenuse. So I'm going to go ahead and start this problem by doing the sine of 35 degrees equals 18 over, and we need the full length of the hypotenuse, so we're going to have to take x plus 18. Now we have an equation that we can solve. One way to do this is by cross multiplication. So we'll have 18 equals the sine of 35 degrees times x plus 18. Don't forget, because this has more than one term, we need parentheses, so we don't forget to distribute. So once we distribute, we will have sine 35 times x. I'm going to put the x up front, so I don't think it's included in the sine. And then we're going to have plus 18 times the sine of 35. In order to solve for x, we need to get this x sine of 35 by itself. So I'm going to subtract this 18 one on both sides. And again, you don't want to use your calculator until your final step so that you are not rounding multiple times. Now that we have x sine of 35 by itself, we can divide to get our final answer. When you type this into your calculator, make sure you are cautious and you add parentheses when needed. So for this one, you will need parentheses around the numerator. So we have 18 minus 18 sine of 35. So this one, you'll have to type 2 parentheses and then do the division of sine 35. If you don't have all of the parentheses you need, your calculator is going to follow PEMDAS, and that's not always going to be in the order we need it to follow. So in this example, we will have x is about equal to, we'll do 13.4. All right. On your notes, you can skip example 5. That one we don't need to complete the homework. And then we're going to complete example 4. This one you might need a little bit of extra room, so if you want to continue down in the workspace for example 5, feel free to do that. So in the image below, the distance from A to D is 32 feet, and they want us to use this information to solve for x, which is the distance between D and C. So for this one, we do have two right triangles. We have this one that I'm highlighting in yellow, and then we have this right triangle on the outside. That includes all of them, all of the side lengths. So we're going to start by setting up equations and seeing what we can do from there. Looking at our smaller triangle, we have the height and we have x, which are the opposite and adjacent, which will give us the tangent of 54 equals h over x. If we look at our outside triangle, we again have the opposite and adjacent, which would be 32 plus x here. We will have the tangent of 38 equals h over 32 plus x. Now these equations you are going to have to solve by substitution. So to do substitution, you have to get one of the variables by itself. The easiest one to do that for would be h in this example. If we look at our first equation, if we just multiply both sides by x, h will end up being by itself. Now that we know what h is, we can plug this into our second equation on top. Now we can go ahead and start solving because we only have one variable. So we can go ahead and start by cross multiplying to get rid of the fraction. And don't forget the parentheses around the 32 plus x because we will need to distribute, which will be our next step here. And you'll notice we will end up with multiple terms that have x with them. So when that happens, and if you cannot combine them, you will want to get them on the same side of the equation. So for that one, this means we're going to subtract x times the tangent of 38. Now, because these tangents are not the same, we cannot combine them like we would combine a 2x and a 3x. So we're going to have to write them separately. We'll have x tangent of 54 minus x tangent of 38. And because we got rid of that, it'll just be equal to 32 tangent of 38. Now, if you look at the left side of our equation, you'll notice both of our terms have an x, which is a common factor. So we can go ahead and just factor that out, and then we'll have tangent of 54 minus tangent of 38 in the parentheses. Then we'll just have to get x by itself by dividing by the tangent of 54 minus the tangent of 38. And you are going to want to make sure you put parentheses around both the numerators and the denominators for this one when you're typing it into your calculator. That way we know for sure that we're going to get the correct value for x. So for this, 32 times the tangent of 38 divided by tangent of 54 minus the tangent of 38. So we know x is about 42. And we're just going to leave it as 42. Then we could use that information to find h, but this one they only asked us to find x. So we don't need to figure out what the h equals, but we would have enough information to solve for that if needed. If you have any questions on this, just let me know. The homework assignment is listed, and don't forget to check your answers.